Welcome, everyone. Thanks for joining us for today's webinar with Nous Infosystems and Synthesized on reshaping software testing with synthetic data, AI, and automation. I am Ashtotra Rupini. I'll be your host for the day. Throughout this session, we encourage you to ask as many as questions you can related to the topic. You can simply type your questions in the Q&A box. And time permitting, we'll address as many as questions we can during the Q&A segment. In today's fast paced software landscape, traditional test data management can't keep up with increasing speed, privacy demands, and AI driven architecture. AI powered synthetic data and automation is just redefining what's possible in modern testing, enabling faster releases and stronger risk coverage. In this webinar, we'll show how teams are integrating synthetic data just directly into the pipelines to achieve continuous, compliant, and high test quality. Let's meet our speakers for the day. We have with us Jay Nair, Senior Vice President, Delivery Assurance, Quality Engineering at Nous Infosystems, an expert in lean agile product development, DevOps, enterprise quality, information security, and continuous testing.
Hey, welcome everybody. Very happy to be here.
We're joined by Zoe Laycock, Product Marketing Lead at Synthesized, specialized in developer-focused solutions and AI-powered test data automation for continuous testing at scale.
Thanks, Ash and Jay. Thanks for having me.
We also have Finn Laford-May, Solutions Architect at Synthesized, with strong expertise in software testing, test data management, and delivering high-impact quality engineering solutions.
Hi all, pleasure to be here.
It's a privilege for us to have you with us today. So I would like to invite Jay. Over to you, Jay.
Thank you. Thank you, Ash. Well, we are going to talk about a very important topic today, but let me talk a little bit about Nous first. So we are all about helping clients reimagine the applications they want to run their business in the future, to rethink the way they deliver those applications to their customers, and to help them actually do it on the ground, leveraging everything we have learned over the 30 years of our experience. And we work with technology partners like Synthesized to combine our services with the state-of-the-art solutions that they bring to the table so that we can help our customers deliver on their promise to their end customers. Over to you, Zoe.
Thanks, Jay. So thanks for having us. And I'm here to give you a quick overview of Synthesized. As a company, we've kind of worked on pushing the boundaries of test data management to the next level by pioneering intelligent test data automation, and I'll come back to that in a moment. Test data automation enables QA and DevOps teams to create and validate and share production-like test data to test environments whilst meeting the highest standards of data security and also compliance. Synthesized Platform's role in this is that it provides an enterprise-grade unified control plane that enables teams to manage the entire test data lifecycle, ensuring that the right test data is continuously available to both developers and testers. As we approach the new year, I guess as technologists, we're all already curious about AI and its impact in 2026 on the development and testing spaces. And it's clear that the next wave of software automation will be data-driven and agentic, where intelligent systems continuously test, validate, and evolve software. And in that context, Synthesized is a next generation solution that provides the essential data layer, test data layer required for this future, and enabling, well, it kind of enables the foundation, if you like, of AI-driven quality engineering.
So why are we even talking about this? Today, the kind of challenges that enterprises and software development companies, teams face has to do with the nature of today's applications. As we all know, there are more and more of cloud native applications being used. They are distributed using architectures like microservices, micro front ends. They're very highly integrated with tens or even hundreds of applications, other systems, and they're increasingly AI powered as well. The frequency of releases tend to be pretty high. There are many teams that have multiple releases every day. And more development teams are using AI to generate code. And again, we have some of us have experienced and others have read about how the code being generated with the help of AI tend to have a lot of quality issues. So that means you need to test more. You need to have a different approach for testing these kind of systems. The industry has responded with increasing use of automation. But if you consider the state of the art in automation, automated testing today, what we have seen is that in many places, those tests tend to be brittle. They fail at the smallest changes that are happening in the application or in the environment. And oftentimes it just takes too much time to run those tests. And you do not often have good coverage of the business risk from the changes in the application for a variety of reasons. And our end customers have very high expectations on quality, rightly so. We are also end customers of the companies that serve us, and we want high quality. We want latest features to be delivered to us at speed. And our companies have to be run cost efficiently so we get our services at the lowest possible cost as well. So all of this puts a lot of complexity into testing today. And when a company or a team is not able to respond with the right kind of testing approach and methods, you run into problems. I'm reminded about the roll out of healthcare.gov about a decade ago. Some of you might remember how disastrous the launch of that platform was. There were some 4 million or so people who had signed up on the platform, but less than 10 is what I read. 10 people were actually able to register on the website on that day. And there was a long investigation into what went wrong. And the finding was that the platform was just not tested enough. There are many other examples of this. The promise that modern day technology and methodologies offer around quality is that you are able to establish a continuous feedback loop on quality through various techniques. Shift left testing, that is testing early in the process, testing often, and shift right, which is about taking observability data from production and feeding that into the development process to be able to prevent defects from occurring. Today, testing teams are able to spin up test environments on demand thanks to technologies like IAC, infrastructure as code. Automated test execution happens automatically in CI/CD pipelines, and there are solutions that can be used to run hundreds of tests in parallel across multiple test machines. And with AI, there are even more possibilities. Test cases can be auto-generated from requirements or from code. You can select your regression test and you can prioritize them for execution based on risk. You have the ability to have self-healing test, that is, test being able to adapt to changes in the application and run without failure. The holy grail of all of this is autonomous testing, and we are some ways there as well. We use AI ML technologies to analyze our test results and gather deeper insights into quality as never before. But with all of this, oftentimes automated testing just doesn't work as well as you would want it to. That is the reality today. What's the reason for that? There are a few reasons. One of the most important of them has to do with test data. And we'll talk more about it, what specific issues around test data lead to this. But we can say for sure that even if you have good automation, if you have poor test data, then, well, you may be running your test fast, but you will not gain the confidence you want in releasing your product to market, even with the latest technologies like AI. So this really is the problem that we want to talk about today. Not just the problem, but also the solutions. So what are those problems around test data? There are basically two ways of getting the data you need for your testing. One is to use production data. The other is to synthetically generate data. Now, it's not very easy to use production data, especially for large enterprises. Sometimes that data may not even be available to you. That might be because of regulations. The production data will almost always contain confidential data that cannot be made visible to a larger audience like the testing team. Or even if you don't have that problem, maybe your product is a SaaS application and the data belongs to your customers. You don't have their permission to use their data for your testing. We all know how nervous we are to allow our data to be used to train AI. It's a classic example. We just don't want that to happen. And so it's not always possible to use production data for testing. Now, even if you can use production data, there might be challenges around it. Maybe there just isn't enough data for high volume testing. And this is often a situation you might face for load testing or stress testing when you have to load the application well beyond its normal use in production. Or maybe you don't have the right data. Production data will have good happy path data. That is data that is created in the codes of the users doing what they're supposed to be doing on the application. But then it's those edge cases that may not be fully represented in production in terms of data. And we all know that it's those edge cases that can actually create havoc with respect to quality. It's really important that you test those edge cases and you just won't have the right data for it. Sometimes you can have too much of data. Data can be so complex, so large that it becomes too much of a burden to use it for testing. And all of these can actually create so much of overheads, process overheads, time, cost, software development. Now, I want to pause here and ask you both, Zoe, Finn, I'm sure that these are things that we hear from our customers and things that we experience. How about you? Do you come across these similar problems or maybe other issues like this?
Thanks, Jay. Yes, we do. They're exactly the sort of challenges that we hear in first meetings with prospects. And diving a bit deeper, they're the main customer pains and use cases for why customers seek us. So let's just take a look at what some of these use cases and problems with test data are. So as you've mentioned, number one is compliance and risk mitigation. Obviously, using production data that may well have sensitive PII data within it. Using that for testing purposes really is risky and in many parts of the world is actually illegal due to the sensitivities around data privacy. So how do you get production realistic test data? that actually enables you to test across lots of different personal circumstances, user behavior circumstances, and across the global regions, and actually stay compliant. So that's one of the drivers why people seek solutions like Synthesize. The second is maintaining static test data environments, which just isn't feasible often due to storage and infrastructure limitations. Another challenge or problem is complex application landscapes. The number of applications and systems that certain enterprises now have, the complexity of those systems, and the dependencies, technical and also in terms of business logic, that makes them hard to test. So often test data needs to be customized to the specific sort of test that you're trying to run, and also give the kind of coverage and complexity that maintains data integrity, referential integrity, and is contextual to the business logic that's being tested in part, or at least of the application that's being tested. Manual processes are the fourth problem. I'd suggest that whether you're at a stage of DevOps maturity, or you're even further where you're looking at AI-driven DevOps, you cannot fully realize the promise of automation, test automation in this instance, if you still have manual processes that are part of it. And so things like manually provisioning and refreshing takes lots of time, is quite labor intensive, and as a result is often causing delays to developers and also to QA processes. So that's where bottlenecks occur. And the fifth challenge that we see often is about how teams have limited access, as I've touched upon, to realistic data that serves the kind of testing that's required. So again, comprehensive, high fidelity, production-like data, rather than using actual production data, is often what is preferred to be able to test comprehensively, to be able to find edge cases, and really increase your test coverage. So they're just some of the challenges and drivers that make people look at and consider AI-powered test automation solutions.
You know, sometimes production data can be too realistic also, right? So I'm just thinking of some cases where, you know, it might have duplicate records created by mistake, or, you know, data, you know, if it's a product that has been in the market for a while, or an application that has been used for several years, it might actually have biases related to certain demographics, which are the vestiges of certain functionalities that used to exist years back. And you don't want to use all of that data, especially if you want to train your AI. You don't want to have that data with those bias used for the purpose. And then I'm also thinking about the subsetting. You know, I know that Synthesize has a really good, strong capability for subsetting of data. And when you subset data for AI use, for example, you need to segregate the training data from the testing data. And if there is overlap, the model might end up seeing some of the training data in the testing set, which kind of invalidates the testing, and you are led to believe that the AI actually is performant, whereas it actually is not, because it's already seen the data, right? In training, in testing, that's why it performed well. So there are those kind of issues as well. It's really there are really so many of these aspects to be considered when you use, whether it is production data or synthetic data, for modern day applications. I'd love to hear your views on this. You know, not just about how do you use a really highly capable product like Synthesize, but how do you use it effectively and successfully so that your objective is served?
Sure. So thanks, Jay. So I think, there's a multitude of ways, and they're all really valid points. I think, the reason that we are able to basically fulfill those requirements is by being AI native, right? And when we say AI native, we're talking about having, pre-trained machine learning models. And being able to really automate a lot of those processes whilst really allowing complete customization of data and configuration of data. We recognize that most large enterprises have incredibly complex landscapes, and data is constantly changing, requirements are constantly changing, and so the ability for us to use AI where appropriate to automate processes, but in hand having the control over that data, because a lot of solutions are either one or the other. We try and make it that perfect middle ground.
Got it.
Yeah, and just to add to that, most of our use cases, our customer use cases, are related to test data and test data management. However, just coming back to the point that you made about training data, historic training data, and best example of this is LLMs, absolutely can have biases built in, and therefore that is one of the reasons to where you have specific requirements around data, is to actually turn to where possible synthetic data solutions to be able to generate customized data specifically for the purpose that it's required, rather than using historic data that may well be out of date and might have built-in biases. But obviously that's mostly relevant to training data for AI systems.
Very cool. Yeah, this is very interesting. Would love to hear more about the automation side of things.
Sure. We talk about it all the time, so we know what it is, but test data automation might be a concept that people are less familiar with. So let me put it simply. You may be familiar with test data management. Tooling around test data management has been around for quite some time. If test data management, TDM, is generation 1.0, test data automation is generation 2.0. Essentially, it's the evolution of test data management to drive higher levels of test accuracy, customization, but also automation for AI-driven development, but also using AI inside, as we do, to actually create much more customizable but accurate, high fidelity production like data and data on demand. And test data automation is the process of using AI to, in our case, to automatically generate, provision, and manage production quality data for test workflows. And unlike manual TDM approaches, test data automation systems like Synthesize can create realistic, compliant test data sets in minutes rather than weeks, which might be what can happen with manual processes. And also, Synthesize is able to, if you input and have kind of a set of data that is representative of what you would like to use for testing purposes. Synthesize uses machine learning to actually analyze the data that it's been given, the set of data that it's been given, to understand the relationships between data fields, data tables, and indeed different databases. And then to actually be able to do two things. One, understand the referential integrity that is involved in complex database relationships. And two, to be able to quickly and easily scale from what might have been 50 records that was fed in as an example data set, and to scale it to demand of whatever size the testing team actually requires. So you can go from 50 to 500 to 5,000 to 50,000 records very, very quickly that meet the requirements of the testing team. So test automation can solve some, if not most, of the critical problems that we have outlined that lead to test data bottlenecks. But that's kind of enough of me talking about it. And what we'd rather do is actually show you rather than tell. So if you don't have any further questions, Jay, I'm going to hand over to Finn to provide a technical demo of some of this and how Synthesize platform works.
Yeah, I mean, we are all really excited to see this demo of the product itself.
Yeah, so I'm going to take you through the platform. A couple of things before I start. We've really tried to build this platform to make it really user-friendly and as simple as possible. You know, a lot of existing solutions, whether it's existing TDM products or whether it's manual scripts, are incredibly difficult to use. So we've tried to make it as easy as possible for the end user. In terms of how our system works, we essentially connect to a source and a target. Now, that source could be production, it could be an existing test environment, and it could be a relational database, it could be a third-party application such as Salesforce, or it could be a file or a schema. And then the target is generally the system under test or test environment that you're testing against. The reason we connect to that source is so that we can use our machine learning models to analyze the structure of the data, patterns in the data, and essentially automatically get you to a really good starting point of what that data should look like. So the first thing I'll show you is just around data sources and how we set those up. So you can set those up in the system. I've got quite a few set up here. But if we click connect data source, we've got a variety of different options. So I've got, these are just the ones I've got, but we've got relational databases. We've got some older things such as DB2 and sort of mainframe. We've got newer technologies such as Snowflake. And as you can see, I've also got SAP set up and CSV. We generally connect via JDBC, but we also have other options available for connections for packaged applications, such as via API or via an agent utility. And then in terms of authentication, we can connect to a secret manager, which of course most large enterprises use. We then also have, importantly, database permissions, which, again, are really key to set. We always want to make sure that that source we're connecting to, whatever it is a read-only connection. We never want to change anything within that. Once you've set up your data sources, you can then create workflows. So workflows are the way that we automatically understand and show what transformation is going to happen to data. Our three main use cases are around data masking, synthetic data generation, and data subsetting. And we can actually do all of those in one workflow. So if I come over to a masking flow, you can see that we have a data as a code approach. Now, this allows us to essentially go down and configure data to the lowest level. But importantly, in this scenario, this has actually all been generated by our machine learning. So I haven't had to do any of this. We do also have a database view or a visual view, which you can achieve the same outcomes, but it's a less code approach. The first thing I'd do in a masking sense is I'd come over to our sensitive data scan. So what I can do is I can run this scan, and this will go off to the source. And again, it will automatically use our machine learning models that are pre-trained to look at the structure of that data, the structure of that database, the different tables, the different column names, the data type, and it will essentially come back and look at also samples of data within those columns. And it will come back with this report, which automatically is identified, in this example, some PII data around first names, last name, emails, etc. It's automatically marked these as sensitive, and this is where a user like myself can come in and either change these or just accept what the system has given. As you'll see, this is on a fairly small data set, but we've got customers at the moment using this across 400, 800,000 tables. So we can scale this up and down pretty well. What I can then do is I can apply those suggested changes. And what that's automatically done is this has basically made sure that this code here has been updated. So this has then taken all of those different parameters, all those different fields that were sensitive, and it's basically automatically just going to mask them. So to show you this, I've got a demo application. So this is a very simple banking application. And for demo purposes, this view here is our production database. Now, within this production database, we've got customers who've got names, emails, phone numbers. Importantly, all of this data is linked together. So every customer has got an account or multiple accounts, and all of those accounts have then been linked to multiple transactions. I've then got a testing database, which has currently got nothing in it. So if I just purely wanted to mask data, I can run this flow. And if I come back over to my application and refresh this, you see that I've now got exactly the same amount of data in here. But if I actually go into the customers, for example, you'll see that all this data has essentially been masked or scrambled, whilst the structure of that data has been maintained. And again, any area where data has been referenced that's the same within the same database, it's been masked the same. So we have a deterministic model that means if the name Finn is used in multiple locations, it will be masked the same. But you're probably thinking, okay, well, this is good and this means I can use it, but actually I want to have more realistic, names in here, for example. I want to have data that needs to meet validation rules and things like that. So we can do that as well. So on top of our sort of basic masking routine, we can also apply data generators. So if I go into this other masking flow, you'll see that, again, for some fields, such as branch name, we've just chosen to mask it. But for other fields, we've actually identified our custom transformers here to actually generate realistic data over the top of those names. So here we're using the person generator. And if I go into this view, it's a bit easier to see. You can see that we've chosen the mode is masking, but we've chosen out of our many transformers here. And again, we can customize this to the lowest level. So whilst we have defaults for the names it generates, we can change that if there needs to be certain rules in place. If I now run this workflow, you'll see that the same data again is still there, but if I come into accounts, you actually see that those names have now been changed and they look really realistic. They've also been linked together. So the last names that have been generated have actually been incorporated into the email. And again, referential integrity between the system has been completely maintained. So that's masking. What we can also do is we can do generation. So what we do with generation is a similar process happens, but it's a few changes. So by default, what happens with generation is that the system is going off again into that source database using our machine learning models, to essentially understand the metadata of that database. Again, it's looking at columns, data types, and it's essentially looking at patterns of data. It's automatically then choosing for you the different transformers that we have to be able to replicate that data for the non-production environment. But it's actually doing more than that. So it's actually, not only is it choosing a transformer to make sure that it's generating the right type of data, it's also doing statistical analysis on that data to understand the patterns of data, the distributions, to make sure that, if that source is production, that you're mimicking production as closely as possible by default. So if I click on this one, and this is account status, you can see that it's basically done, showing the distributions of those statuses in production, and it's going to mimic those exact statuses in the non-production environment. This is also where we can customize this, though, for edge cases and negative scenarios. So I could come in here and I could say, I want 100% active accounts. I want 0% active accounts. I actually want to add a new status in here that doesn't exist, to see how the system fares with that. So again, all of this is completely customizable, but importantly, all of this is done for you by default. And again, this scales up and down really, really well. What I can do then is I can scale that data up. So I can choose to scale that data up by 5 times, 10 times. I'm just going to do 5 times for now, just to show an example. So again, if we come over to our example application, you can see now that that data has been scaled up. And you'll notice that not all of it has been scaled up. And that's because within the config, we actually defined 5 times the amount of data at a global level, but actually at different table levels, we defined different values for what we need. So we can really control this at the highest or lowest level. What you'll also see is that, again, new customers have been generated. And now they've been generated completely from scratch. So they haven't been, unlike masking, where masking took the original values and passed some of that through and then changed some values. All of this data has completely been generated from scratch, whilst understanding and looking at the patterns of that data. So again, you can see the linkages between data, but importantly, the referential integrity has been maintained. So for every customer that was generated, one or more accounts was generated. And for all of those different accounts, multiple transactions were generated. Again, using the statistical analysis, things like amounts actually appear realistic because it's basing it off, the minimum, the maximum, the median values. They exist in production. And again, this is all completely in our control. In terms of subsetting, we can do subsetting across either generation or masking. I'm actually just going to show it on masking. So I can choose to subset, 50%, so I can essentially halve that data. We've currently got a customer who has got about 30 terabytes of data in production, and at the moment they copy all of that over to about 5 different test environments. Now, that's incredibly inefficient, but also incredibly costly from a storage point of view. So we can subset this data down, and what will happen is that it will automatically understand all the different relationships between data to make sure that those links aren't broken when you reduce the amount of data. So if we come back in here again, as I was mentioning, you can see these numbers don't quite add up to 50% of what we had. And that's because it's got as close to that number as possible, whilst making sure that, again, all that referential integrity is maintained, and that, for every customer, they still have at least one account, and all those accounts still have at least one or more transactions. This really allows you to, again, customize and configure data in any way you need. We also have full audit logs in which we can see, who ran a workflow, how the workflow was run, and also we can generate a report to show, for each different database and table, what transformation happened, how many records did we generate, and also the different transformer that was used for that exact column. We can also integrate with CI/CD. So we have native connections to GitHub Actions, and we also have an API which can be exposed to essentially integrate into your pipeline. Lots of our customers go down this route, and means they can generate their data, do data refreshes continuously through when they run their pipeline. Another key thing to mention is how we deploy our software, and this is a question that comes up a lot. So typically we deploy within the customer cloud. We can also deploy on-premise if we need. And the reason we do that is obviously, as some of the challenges we were mentioning earlier, security is a really, really massive, big thing. And certainly with the use of AI, it's getting even more important. So from our point of view, we deploy it within the customer environment. So the data and everything is completely in their control. We at Synthesize can't access that data, can't access the platform. So everything is completely in their control. In terms of how we operate, we also don't store any of that source data. So even though we may connect to production, we don't ever store any of that data. And all transformations are done in transit. What this also means is that, when we're masking values, for example, it's a one-way transformation. So, someone looking at a masked data set will never be able to get back to that original source data. That concludes the demo. I really hope this has helped, and I really look forward to any questions in the Q&A section.
Thank you, Finn. We actually have a few questions.
I wanted to make a couple of comments here. Finn, again, thank you. This was really, really very interesting. I'm sure this will be very interesting for our audience here. What I really like about the platform, there are many things to like about it, but one thing that stands out is the simplicity of use. Because some of these algorithms that I know are really complex. Like, for example, the masking that you were referring to. It's really important that it be not possible to reverse engineer and get back to the original data. So, so these are not easy to accomplish, but the product team has done a really fine job of hiding all that complexity from the user and the user experience itself. And this is something we know from having seen this at close quarters for some time now. Is one of the factors that really differentiates Synthesized from many other products that are available in the market. They just tend to be quite complex to use, lots of bells and whistles that many users would never have to even touch. And they also have to pay for all of that, all of the capabilities that they don't really use. So overall, Synthesize can really bring in a lot of efficiency into the entire software development process by through the automated management of test data on demand and using self-service. So the testing team does not really have to depend on other teams or individuals to get the data they need. So very cool, I would say.
Thanks, Jay. I mean, we've tried to, that's partly about the fact that we are trying to design a product that, as we said, can do multiple things and not necessitate enterprise teams to and busy teams to have multiple tooling within the stack to do certain things. So you'll see a plethora of solutions out there that do one element of what Synthesize does, might do data masking. That's probably the most common one. And what we've recognized is there's a whole data life cycle that needs to be managed, but also that there are multiple stakeholders and people that actually need synthetic and synthetic test data generated. And within what can be complex multi-engineering team enterprises, there could be a plethora of different stakeholders, and therefore being able to either operationalize test data generation to order, or being able to enable people that are not necessarily developers or DBAs to be able to specify what their data requirements are. That's what the platform is designed to do. And so really it's by design, it's meant to enable one single platform that can do multiple test data operations that are needed around generation, provisioning, subsetting and masking.
Yep. Cool.
There's a few questions from the audience. Stephanie has got one question. Is Synthesized able to connect to SAP systems, or the connectors SAP certified?
Yes, we can connect via SAP. We've got two routes. We've got three routes, but we can either connect via the underlying database via JDBC, but usually within large enterprises that's locked. At the next level, we can go via API to the application layer, which is normally what we do. And the third option, if that's not available or doesn't work, is that we have a utility agent where essentially we can do a kind of import, export, and make that work.
Okay. Stephanie has one more question. It is for masking different entity types with real world values. Is that a hard-coded list of, for example, first name, last names? Or does it use a library or machine learning to generate?
So that's a great question. So it's not hard-coded, but it is deterministic. So they're pre-trained models on, the machine learning models are pre-trained already. So it's not doing, they don't have to be trained on your data, but it's not a defined set. Essentially, it's using its logic to go off and generate, new names, but it's making sure that, like I said, when there's multiple of the same value, that's generating that same value consistently. And again, you can control that, but ultimately the values there are guaranteed to be unique, where appropriate. And again, we can scale that as big as small as we need.
Okay, thanks, Finn. One more question from Ilhan. What logic or formula do you use for subsetting? Can that be custom defined?
So another great question. The answer is yes. Pretty much everything can be customized. To be honest, obviously what I showed in the demo was only quite a small chunk of customization. By default, the logic it's using is essentially it's just taking, like I mentioned, it's taking let's just say 50% of the data. It's taking that 50% whilst making sure that no relationships within the data are broken and are maintained. But you can essentially define custom logic for subsetting, for masking, for generation. One thing I didn't quite cover is in terms of our generators and sort of transformers that we use. The person generator that I showed is fairly simple, but we have some really complex and cool transformers that allow us to, do a plethora of things. One of which is a scripting transformer, which is basically the do whatever you want transformer. You can essentially apply any logic, whether that be business logic, complex logic, really complex scenarios within there. So, we work typically across very large, very complex organizations. And I'm happy to say there hasn't really been a scenario we haven't been able to cover yet.
Thanks for answering that, Finn. Unfortunately, we don't have time for additional questions during this session, but rest assured, we'll respond to all your queries. There are so many queries I can see in the question and answer box right now, but then we'll answer those queries via email and share today's presentation as well with you. So before we sign off, I would like to remind you that Nous Infosystems and also Synthesized are here to support you with any questions or assistance that you have regarding software testing. Reach out to us to this email ID that's displayed on the screen for you so you can connect with a team of experts. And with that, I would like to thank you for joining us for today. We deeply appreciate you for being here. Have a wonderful day. Goodbye.